Welcome to Carbon. We're a technology company changing the way the world makes things. Specifically, 3D printed things. We didn't start out trying to change manufacturing forever.
We didn't?
No, we didn't.
We started with the simple goal of making 3D printed parts better.
It's 25 to 100 times faster, which is game-changing.
But we quickly realized that with our combination of technology and materials, we could make real parts with mechanical properties and surface finishes that make injection molded plastics obsolete by comparison. Embracing the idea that speed to production isn't an obstacle anymore. It's the only way forward. And our partners share our enthusiasm for reinventing the rules. Partners who are manufacturing at scale, making millions of real products.
Like us?
Yeah, like you. In partnership with Adidas, we've created a midsole that shouldn't exist so that they could make a shoe that shouldn't exist. Light, super flexible, highly durable, and printed straight from liquid. A marvel of design and function, this shoe defies logic. And whether you want to make 1 or 1 million, this is true, customizable, and on-demand mass manufacturing. This is not a publicity stunt. This is a revolution. And we're just getting started. Stop prototyping, start producing.
The state of 3D printing today goes two ways. There's people who are developing machines that can print with materials that we currently use through traditional manufacturing processes. And there's people that are developing platforms based on multiple materials. And this will enable a broad range of new applications by being able to manufacture products that we were not able to manufacture through traditional techniques. We've developed a low-cost, multi-material 3D printing platform that can print with up to 10 materials, and it's machine vision enabled. So we use machine vision techniques to enhance or amplify the capabilities of current multi-material printing technologies. We call our project Multifab. And with Multifab, you integrate these two worlds of traditional manufacturing and 3D printing, and by putting them together, you can create a whole new range of objects that we haven't been able to make today. The machine vision system integrated in Multifab allows us to easily and very quickly calibrate the printing system. Second, we use machine vision to integrate existing components into the printing process. So imagine we put components into the printer's build platform, we scan the objects, and then we use that 3D geometry information to print objects around those existing objects. Right now, a big portion of the 3D printing kind of hardware that's available is focused on printing form and on objects for prototyping. The holy grail is to print things that are fully functional right out of the printer, combining multiple materials with many different properties, but also existing objects that have some inherent functionality. We printed lenses on top of LEDs. We put this existing LED into the printer and we print a lens on top. Designers and engineers are used to designing with one material, so the whole design paradigm, like how we actually design products and objects, will have to change, and that's going to require new hardware, that's going to require new software, and that's going to require whole new platforms, and we're going to have to change the way us engineers and designers think about design and creating products and objects.
MIT researchers have created a working hydraulic robot from a single 3D print, meaning the robot can move right off the printer after it's done, no assembly required. The tiny six-legged robots are out of MIT's CSAIL Computer Science Lab and are made of both liquid and solid parts that are fully functional right after the printing process. The group used a printer from Stratasys, one of the largest 3D printer makers, and it can work with 8 different materials at the same time. MIT is known for producing intriguing robotics projects. It's hooked up with DARPA, NASA, and other organizations to create humanoid robots in the past. This fully assembled robot from CSAIL isn't exactly C-3PO, but it can walk off the printer using built-in bellows. The robot only weighs about 1.5 pounds and is 6 inches long. The little bellows allow fluid pressure to build up to the legs and push the tiny robot forward in a walking motion. The new MIT technology could have some pretty big implications in manufacturing's future. Think about printing off other household machinery in one go and just adding batteries. It also opens up new possibilities for how we might design our future robot overlords. Think about it. What happens when the robots figure out they can just print more of themselves with the flip of a switch?
We're here at Zoom Pizza, where they make pizza with robots. We're gonna see how they do it, but first, let's order a pie.
At Zoom, humans and robots work together to make pizza, and you can see it happening from start to finish. The first step in the process is that the pizza is put onto the line. We use optical targeting and a pretty sophisticated vision system to tell each robot when to trigger. So your pizza has tomato sauce on it. That means Pepe, our tomato sauce dispensing robot, knows when the optical target reaches its laser to dispense the exact perfect amount of sauce, which he did just now. The next, Marta, our sauce spreading robot, will take that sauce and spread it into a spiral. The next step in the process is done by humans. Noel is one of our amazing pizzaiolos. He's gonna take that pizza, adjust any imperfections, and then actually begin to add cheese and toppings. The humans have 22 seconds to complete the topping step before Bruno, the next robot, takes the pizza off of the line and puts it into the par bake oven. Bruno is a very powerful robot. He's a 6-axis robot. You've seen this kind of a robot mostly in manufacturing settings. We're using this robot to make pizza. So that means we need to fine-tune this robot so that it can actually mimic what a human would do with a similar tool. This is a totally compostable sugarcane-based box that's designed to keep pizza incredibly delicious because all of these ridges keep the pizza from getting soggy. So your pizza's ready.
Oh, looks so good.
So Georgia, Marta, Pepe, Bruno, the pizza making robots that you saw today, allow us to reduce the amount of time for each individual pizza preparation step. They allow us to reduce the error rate because robots are designed to make the same motion consistently and perfectly. And they also allow us to invest more of our resources in high quality ingredients as opposed to repetitive manual labor steps.
Tell me a little bit about some of the other ways that you guys have been innovating, especially in how the consumer interacts with the brand.
We want people to be able to get the highest quality food in about half the time. Our average delivery right now is 22 minutes. And that's 22 minutes from the second that you place the order on your phone or computer to the time it actually arrives at your door. So your pizza is never sitting around. And we have this team of pilots that are tied into a logistics and routing program that allows them to optimize their routes and minimize the amount of time that it takes to drive to your door.
You guys are already using robots, but what's next?
You know, the next most important step for us is what we call baking on the way. In the center of it is our hub, our home facility here, and then each node is an individual delivery vehicle. Those delivery vehicles have 56 proprietary mobile ovens that are wired to actually cook pizza while it's being delivered. And Zoom owns the patent for this technology, which we call cooking en route, or better known as baking on the way.
And so right now it's just pizzas, but am I going to be able to get like beef bourguignon someday via robots?
You know, right now we're hyper-focused on giving you the highest quality pizza that we possibly can, and so that means we have to be laser-focused. But you know, it's a big wide world, and there's certainly additional opportunities to innovate beyond pizza.
Templasco was founded in 1985 in Carthage, Tennessee. In 1989, Templasco expanded into Lafayette, so now it is currently expanded to 100,000 square foot of manufacturing facility and 86,000 square foot of distribution facility. While the economy is doing very well, we are having a very difficult time to get people to work, especially on the off shifts in the injection molding floor. Our customers are trusting us to be able to support their business, so we have to find a way to meet their needs. We've been able to achieve that through innovation, technology, and robotics. Initially, especially with Sawyer, there was some anxiousness because it was new, but the people have been very accepting of him. They actually like him. They like seeing his face and his eyes and being able to interact with him. He shows up every day to work, he doesn't complain, and he does his job every single day.
Sawyer is currently working on a task of a defroster nozzle assembly for a large automotive company. Here you see we have the front and the rear. When they are brought to the operator, she takes the rear and the front and she snaps them together. And from there, after snapping them together, she will add 2 foam pieces and a label, and she will place it onto the fixture. The fixture will then tell Sawyer to come and pick it up. He will visually inspect for foam, label, and the clips. And then he will drop the part onto the welder. He will back out, start the machine, and wait for another part to be loaded. Once the part is completed and the welder has cycled, Sawyer will come and pick it up and then go and drop it off at the drop.
威盛觉得这就是公司一直寻求的高效解决方案的关键。
这样能给我们提高生产力，更快速地响应市场需求。
Sawyer 现在主要应用在5种类型的工位：底盒上料除尘、端子排上料组装、上电测试及扫码、上盒上料组装及载波上料组装。Sawyer 正在端子排上料组装工位作业，自动感知流水线底盒阻挡到位。 取底盒置于操作台，组装制具，自动感知物料周转箱到位。取端子排，通过定位装置修正来料偏差，将端子排装入底盒，取电表组件放入流水线，完成一次作业。Sawyer 在总装线上流水作业，较此前生产效率提升45%，不良频率降低50%以上。
China has launched a major initiative. It's called Made in China 2025. It's part of a bigger program the goal is to make China the #1 manufacturer globally, not just for cheaper parts or inexpensive parts, but for all parts, so including a lot of high quality parts, by the 100th anniversary of modern China, 2049. And what they've recognized is that over the last 30 years, what they've been really successful at has been a low-cost labor region. And so we've all pushed a lot of our manufacturing over there if we have a high labor content in order to be able to compete on the global stage, because the alternative was to try to hire a bunch of people in the US cheaply. And I don't know about you, but I'd rather have my labor costs be high, not low. I mean, we didn't want to compete. But what's fascinating about this period in time right now is they recognize, and many companies recognize, that we're switching from what's going to drive competitiveness over the next 30 years is not going to be low-cost labor. It's going to be utilization of technology that allows your factories to learn in a very adaptable, flexible kind of way, and then gain value in the supply chain as a result of that learning. So you would think countries like the United States, where we're really good at innovation, we're really good at technology, we'd be the ones out in front. China is subsidizing the deployment of every single robot in China. If you want to deploy a robot in China, they'll give you some money to do it. If you want to create a company to go build robots, they're going to give you money to do that too. So there's just this massive push going on in China right now. They're going to try and fail and try and fail and try and fail and try and fail and try and knock it out of the park, and by then it's too late.